All right, today we are doing our last section of notes for Chapter 2. We are going to prove angle pair relationships. So we will be using properties of special pairs of angles. So it will be important for us to recognize those relationships and understand what they mean. For our warm-ups, if the measure of angle 1 is equal to 90 degrees and the measure of angle 2 is equal to 90 degrees, then the measure of angle 1 equals the measure of angle 2. There could be a couple different possibilities for a reason here. Why would we say that measure angle 1 equals measure angle 2? Okay, they have the same measure. So if you were to write same measure, I'd probably take that. I think yesterday some of us talked about the definition of being equal to each other means they have the same measure. Same measure, definition of equal. I think even if you were to use substitution here, I could see that being an option. Substitution would be fine here. Something along those lines. Okay, now things that would not work would be things like definition of congruence. Why would that not work here? Good. We only have equal signs. We don't have a congruent sign anywhere. So we're definitely not using congruence there. All right, if segment AB is, what is that symbol? Perpendicular. If segment AB is perpendicular to segment BC, then angle ABC is a right angle. It could help you to draw those segments. So segment AB and then BC means it would have to come from that same point B. Okay, so perpendicular means what? They intersect, but more specifically, they intersect at a right angle. So if they intersect at a right angle, then of course, angle ABC is going to be a right angle. So there we use the definition of what? Good, definition of perpendicular. I'm fine with just using the symbol for perpendicular. If segment FG is congruent to segment RS, then FG is equal to RS. Remember, when we take away the bars and we're putting an equal sign, we're talking about their measures. What would our reason be? Ataya? Very good. Definition of congruence. You can use your definitions forwards and backwards. What I mean by that is if you were told that they were equal and then you're saying they're congruent, that's also definition of congruence. If you were told you have a right angle and then you're saying you've got perpendicular lines, that's still the definition of perpendicular. You can use your definitions forwards or backwards. All right, these theorems are really not anything new. We're just restating them all together. So the right angle congruence theorem states that all blank angles are congruent. All right angles are congruent. The congruent supplements theorem. If two angles are supplementary to the same angle, or to congruent angles, I'm going to use the symbol there, then they are congruent. If two angles are complementary to the same angle, or to congruent angles, then they are congruent. If two angles form a linear pair, then they are, very good, supplementary. And the vertical angles congruent theorem states that vertical angles are congruent. All right, first up, write and solve an equation to find x. Use x to find the measure of angle FKG. Now, let me just start this off by saying I know you could find the measure of angle FKG without x. That is possible, but we're going to follow their directions. So first of all, we need to write an equation that we would be able to solve for x. Maje?
4x minus 1 plus 113 equals 180.
Very good. These two angles form a linear pair. That means that they are supplementary. That means they add up to 180. 4x minus 1 plus 113 equals 180. We wrote our equation, now we have to solve it. To solve this, what would I do? Combine like terms. We end up with 4x plus what? 112. To keep solving, we would. Good. Subtract 112 on both sides. We get 4x equals 68. Last step to solve. Divide by 4. What do we get for x? Okay, x equals 17, but then to finish this, they want us to use x to find the measure of that angle. We're using x, that means we're doing what with it, Sydney? Oh, well, your voice changed, Sydney. Yes, we would plug it in for x. Okay, so here it is plugged in for x. We could label that measure angle FKG. That's what we're finding now. 68 minus 1 gives me 67 degrees. Measure of angle FKG is 67 degrees. All right, on our next one. Again, we are writing and solving an equation to find x, using x to find the measure of angle AEB. This time, we have to find x to find AEB. We don't have enough information to know what it is otherwise. So the angles that they labeled, what is their relationship? They are vertical angles, which means they are the same or congruent. So who can tell me what the equation is? Ariana. Very good. We set them equal to each other if they are congruent. To solve this, I need all my x's to be on the same side. So what should I do? Subtract 3x. When I do that, what do I get? X plus 18 equals 4. Next step. Oh, it is minus 18. That will help. Thank you. Minus 18. Okay. Next. Very good. We add 18. We get x equals 22. Now, when they ask us to find the measure of angle AEB using x, is it going to matter which one I plug it into? No, because they are equal or congruent. So which one do you want to use? Okay, I heard 3x plus 4 first. So even though they asked for AEB, we're using the other one because we know they're the same, so it doesn't matter. 3 times 22 plus 4 is 70 degrees, so the measure of angle AEB is 70 degrees. All right, starting proofs shouldn't be scary because when we start them, what do we always start with? Our given, so we can get something down. So when we set this up, my first statement, JK is perpendicular to KL. I'm going ahead and listing both. I know yesterday's worksheet, they split the givens up sometimes. If you prefer to split them up, that's fine, but I prefer to write them all together. So, my first reason, given. Look, we got some points. Better than nothing. Okay? After that, this is generally where people get a little lost in the sauce. So, use what they told you, mark it in the diagram, and your next statement can be what that means. So what does it mean for JK to be perpendicular to KL? What could I mark on my diagram? A right angle. So I could say on step 2 that what angle is a right angle? Angle JKL is a right angle. I'm fine with RT for right and this angle symbol for angle. Okay, which other one is going to be a right angle? We'll go ahead and put that for step 3.
Can we just put like K and L because that's where our proof is going to be?
Oh, that's a good point. Yes, I think Kara brings up a wonderful point. I was naming it with all 3, but Kara looked ahead and said, well, they're just talking about K and L because there's only one angle at those. So yes, Kara's right. We could just call this angle K and call the other one angle L. Okay, they're the same angle, so I'm fine either way. But Kara's right, it will flow a little better this way. So my reason for 2 and 3 is going to be the same reason. Does anybody know what it is? Somebody started saying it.
Definition of perpendicular.
Very good. Definition of perpendicular. Because we had perpendicular lines, we knew we had right angles. So for 3, I'm just going to use the little quotes because it's the same reason as number 2. Okay, and we can also mark that other right angle in the diagram. Now, if we know they're both right angles, what do you think we're ready for? The proof part. We can already say that angle K is congruent to angle L. And what allows us to say that? Not kind of. If you wanted to use definition of congruence, we'd have to take this a couple steps further. But there is a theorem on our front that allows us to do this.
Right angle congruence.
Good. The right angle congruence theorem tells us that all right angles are congruent. I shorten it right to RT. I use angle and congruent symbols. Theorem you can shorten to THM. If you want to write out all the words, that's also totally fine. The right angle congruence theorem told us that all right angles are congruent. So if we said they're right angles, we can say they're congruent. All right, example 4. Let me set up my chart. We were given a lot of information here. So let's just start listing it. Angle 1 and angle 2 are supplementary. Well, there's a vocab word. We should probably know what that means. Angles 1 and angles 4 are supplementary. And then also they told us the measure of angle 2 is equal to 45 degrees. Okay, so for step 1, all of that was given to us. Again, if you'd like to list your givens out separate, that's fine. I like to just get them all on there. Step 2. So they told us angles 1 and 2 were supplementary, and also that angles 1 and 4 are supplementary. Yanni?
So would it be they equal to each other?
What are?
That both the angles.
Which 2? Give me their numbers.
Can 1 and 4 be supplementary? Oh wait.
1 and 4
3
are supplementary.
3 and
3 and 2 would also probably end up being supplementary. But I think from what they told us in those first 2 lines, we could say that 2 angles are congruent using one of the theorems that was on our front. Maybe the one that involved supplements. So we can use that, but using that, which 2 angles are going to be congruent? I tell you. Very good. Angles 2 and 4. So angle 2 is congruent to angle 4. The congruent supplement theorem said if 2 angles are supplementary to the same angle, then they are congruent to each other. Okay, so that's our reason, the congruent supplements theorem. I'm fine with a little bit of shortening of some of these words. However, do not give me acronyms that I don't know what they mean. For example, if you put CST for congruent supplements theorem, that's not a real acronym that we use. So don't put that down. I won't know what that means. Questions about step 2? Okay? So we are told that the measure of angle 2 is equal to 45 degrees. So to go from congruence to talking about measures, I need to put a step here that doesn't talk about the angles being congruent, but instead talks about measures being a little word, begins with an E. Equal. So what do you think my statement's going to be?
45.
We're not pulling in the 45 yet.
Angle 2 equals to angle 4.
The measure of angle 2 is equal to the measure of angle 4. They started pulling in equality with measures. So that means we need to switch gears and talk about measures being equal. Why am I allowed to make that third statement? Very good. Definition of congruence. If they are congruent, their measures are equal. Okay, now using that last given, what could I do? Instead of putting measure angle 2 here, what could I write? 45 degrees. I could put 45 degrees equals the measure of angle 4. What did I do there?
Substitution.
Very good. Substitution. We replaced measure angle 2 with 45 degrees. Substitution. Am I done? No. What do I need to do on my last one? Switch it around. They didn't want 45 degrees equals measure angle 4. They wanted measure angle 4 equals 45 degrees. What allows me to do that? The symmetric property. Whoop. All right, example 5. Here's my chart. My first step is to say what? Good. Angle 4 is a right angle. How do I know that? It is given to me. All right, here we have a few different statements we need to make based on our diagram. Ataya, do you have a thought?
We say that angle 2 and angle 4 are a linear pair.
Angle 2 and 4 would not be a linear pair because they're across from each other. We could say angles 2 and 4 are congruent, but I don't know if that'll help us yet. So let's start with angle 4 being a right angle. And we know that angle 4,
Well, angle 2 is a right angle also.
Sure, we could. Oh, okay. That's not where I was thinking about going, but we could say that. So, sure. If we want to go back to Atea, were you the one that said 2 and 4 were congruent? That's not where my mind was, but now that Yanni said that, sure, we could go that route. My mind was going somewhere else. There are several ways we could do this proof.
Where was your mind going?
My mind was going with the linear pairs. Okay. How do we know angles 2 and 4 are congruent? They are vertical angles. Okay, we will have a couple steps in here that I think you might not like or you might think are extra, but that's okay. We'll get through it. So if angles 2 and 4 are congruent, what does that tell us about angle 2? Okay, it's also a right angle. What do you think your reason would be? Nope. I would say right angle congruence. We knew it was a right angle because angle 4 was also a right angle, and all right angles are congruent. You could word it a couple ways. Right angle congruence is where I would think that comes from. Again, this isn't how I initially did the proof, but we can get it there. So the part that I think some people might not necessarily like, but this is where we have to go. If we are going to be talking about supplementary, we need to be talking about these measures. So far we've been saying right angle, right angle, right angle. What does that mean? It measures 90 degrees. So for step 4, we need to say measure angle 2 equals 90 degrees. Measure angle 4 equals 90 degrees. If you want to make that 2 separate steps, you can. But I would just put them on the same step because it is the same reason. How do we know that? Definition of a right angle. Okay? Before we can say they are supplementary, we need to make one more statement. What do you think that statement's going to be? Good. We've got to say that the measure of angle 1, or sorry, measure angle 2 plus the measure of angle 4 is equal to 180 degrees. How do we know that? Addition, really. Like, not the addition property, but if we were to substitute those in, then that's, see, this is why we can get there. This does make sense. I just think the reasons are a little sticky. Angle addition doesn't work because we're not adding 2 angles that are next to each other to get a larger angle. So I would just say adding 90 plus 90 is how we know that. The reasons doing it this way are just a little less clear. But we definitely can get to our prove now. How do we know that angles 2 and 4 are supplementary? It's a definition. What definition did we use? The congruent supplement theorem we didn't use. That's how I was going to do it, was with congruent supplement theorem. How do we know that, oh, not 2 and 2. How do we know 2 and 4 are supplementary? because they add up to 180, so that is the definition of supplementary. Definition of supplementary. Okay, if we had used our linear pairs and we had used our congruent supplements theorem, there is a completely different way we could have gone about this proof. That doesn't make this way wrong. It just made some of our reasons a little sticky, a little less clear. All right.